Okay, we're back with session 3 out of 6 for Thursday's class. Now, let's figure out how much you actually paid to the bank. If you look over there, your total payout to the bank is RMT. So you paid $701 per month, times 12 months, times 25. So your whole cost was $210,300 after 25 years. What did the bank made? You pay them $210,300. They gave you $97. They made $113,300. They're making out like bandits. Okay, and that's your loss. And don't forget, you have to add the $97 to the $30,000 down payment to get your cost of the house. Okay. Now what we're going to do is we're going to do a backwards one, and where we need logs. Okay, so I'm on number 17. And it says here, $1,200 is deposited at the end of each quarter. So we have a quarterly payment, M equals 4. In an account that earns 7.2% compounded quarterly. So R equals 0.072. How long will it take? So how long until account balance equals 60,000? Now notice, in your account, at the end of T years, so I want to find T, you're going to have 60,000. That's your future value. If the value in your account at the end of T years was 0, that would then we were talking about a present value problem. We're talking about a future value. We're talking about paying at the end of the month. That's an ordinary annuity. So this goes back to section 6.3. So we're talking about S now, given your payments, and now the formula reverses. Divided by R over M. All right, so let's put in what we know. We're paying $1,200. 1 plus 0.072 divided by 4. M is 4 and T we don't know. Over 0.0. Now we might have done this before, but it's always good to go over it because a lot of you have problems finding T. So let's figure out some of the things here. 0.072 over 4 is, let's just do it out. I know what it is, but okay, so let's just do it out. 0.072 divided by 4. It's 0.018. So 1 point raised to the 4t minus 1 divided by 0.018. Now we know S though. S is 60,000. Without knowing S, we'd be pretty much screwed here. So 1.018 to the 4th. Yeah, I can't do anything with that because I don't know T. So what I'm going to do is I'm going to simplify this equation by doing two things. Okay, so here's what I want to do. I want to do 1 multiply both sides by 0.018. So I'm going to multiply this times 0.018 and this times 0.018 because that cancels. So 60,000 times 0.018 it helps to have this is 1,000. No, 1080. So 1080 equals 1,200 times 1.018 to the 4t minus 1. All right, the next thing I want to do is divide both sides by 1,200. So the second step, divide both sides all right, so dividing this side by 1,200 and divide this by 1,200. So let's see what we get. We get 1080 equals 0.9. 1,200's gone. 1.08 raised 1.018 raised to the 4t minus 1. Now what we're trying to do is isolate the 1.01 to the 4t. That makes the log a lot equal. So I'm going to add 1 to both sides. In order to get that 4t power down on the same level as 1.018 and turn this exponential into an arithmetic problem, I take the log of both sides. I always use the natural log. My calculator does not take logs to anything but the log to the base e, natural log, or to the log to the base 10. I prefer the natural log. Now I use log rules. Log rule, damn it. These erasers keep wanting to go down into this black hole here below my desk. Hopefully there's a white hole at the other side, which might create a new universe of erasers. So I'm going to use a log rule. And the log rule is going to say log, let's say m raised to the x equals x. Well, let's say b raised to the x because I already have an m. Log of b. So in this case, b equals 1.018, and x is what's in the power, everything in the power. If there was a negative in there, it would be negative. So therefore, we go back to this equation, and now we have 4t natural log 1.018. And now we can use standard arithmetic. I'm going to divide both sides by 4 log 1.018. That gets rid of the 4. That gets rid of the log. And I now isolated my t, which was my intent. The natural log of 1.9 over 4 natural log of 1.018. Now let's take the natural logs. The log of 1.9 equals 0.642. And we can do this together. 4 times the natural log of 1.01 equals 0.072. So 0.642 divided by 0.072 is 8.9 years. So it's going to take me almost 9 years to what was the problem? Okay, 17.
I think you were having a future value of how long would it take to get to a certain...
To reach $60,000.
Yeah.
So after 9 years, we will have $60,000 in my account. That is the future value. Okay? At t equals 0, we had nothing. It was only what we put down the first month, which was 17 was $1,200 at the end of the month. We started the annuity at 0 and didn't pay till the end of the month. All right. There is a problem like this on the final. You got to use logs. They're all the same. Isolate your power until there's nothing multiplying it, nothing dividing by it, and nothing added to it. You got to make it lonely. Remember what I said before? Get the close relatives gone and then get the distant relatives gone. Get the close relatives gone by dividing and multiplying. Get the distant ones by adding or subtracting. It's like what my father used to say about relatives when they visited our house. He used to say after 3 days, the fish starts to smell. That meant arrivederci after 3 days. Okay.
We're 12 minutes into this.
12 minutes into it. Okay. Now what I want to do is a refinancing problem. Okay, and it is number 21. So now there is a refinancing problem on the final. This is number 21. So let's see what we give here. Refinancing is always the original loan or mortgage. So let's see what the original on a couple borrows $180,000. So it's mortgage $180,000. That's the present value at time 0 at 5.4%. Compounded monthly for 30 years. How much time we have left?
2 minutes.
Okay, so the second step is the new refinance loan. And I put a question mark because it might not be worth it. Okay, and they're going to refinance at 4.8%. Still monthly. And they're going to take 25 years. And there's a one-shot refinance cost. Not much, $550. How we doing?
1 minute left.
Okay, so A, find the amount to be refinanced. That is the unpaid balance plus the refinancing costs. Okay, we'll stop here.
Okay.